Hello friends, welcome back. In the last session we have seen some examples related to differentiation of inverse trigonometric functions using product rule. Now let us see a couple of examples and quotient rule so that we can finish this and we can move to the next topic. So now how to find out the derivative of tan inverse of cos x by 1 plus cos x. Now at high level I see, if I start from outer to inner, I see tan inverse of a function. Now what's the derivative of tan inverse x? Let's write it down here. D by dx of tan inverse x is equal to 1 by 1 plus x square. We have proved that. You can refer back to that. Okay. Now we want to find out what's the derivative of tan inverse of cos x by 1 plus cos x. So I will say y dash equal to derivative of this tan inverse of cos x by 1 plus cos x whole square, that is 1 by 1 plus x square. Now what is the value of x here? This is my x, that is cos x by one plus cos x whole square. Then after that, if I move to the next level, I see cos x by 1 plus cos x, which itself is a ratio or quotient of two functions. So I have to apply again u by v rule on that. So I will say, first step I will say d by dx of cos x by 1 plus cos x. We'll take it to the next level, we'll write the next step. So this is nothing but, can I get 1 plus cos x whole square divided by 1 plus cos x whole square plus cos square x. Now that I have to multiply with d by dx of cos x by 1 plus cos x is in the form of u by v. U and v, u and v, and you know the formula, u by v differentiation is v square, v into u dash minus u into v dash. So let's apply that. We will have d by dx of cos x by 1 plus cos x. I will have 1 plus cos x whole square. After that I will have 1 plus cos x multiplied with d by dx of cos x minus v into u dash minus u into v dash, that is cos x into d by dx of 1 plus cos x. So let's try to simplify that. We will have 1 plus cos x whole square divided by, if I simplify this, I will have cos square x plus cos square x, 2 cos square x plus 2 cos x plus 1, then 1 plus cos x into minus sin x. Can I write it as minus sin x into 1 plus cos x minus sin x into 1 plus cos x minus of cos x into minus sin x divided by 1 plus cos x whole square. Let's try to simplify this now. Our next step will be the last step, so let's write it down. Before that I can cancel 1 plus cos x whole square and 1 plus cos x whole square. So my last step will be minus sin x into 1, that is minus sin x. Minus sin x into cos x is minus sin x cos x. Minus of minus is plus, and cos x into sin x is sin x cos x divided by 2 cos square x plus 2 cos x plus 1, which is equal to minus sin x cos x plus sin x cos x cancels out. I will have minus of sin x divided by 2 cos square x plus 2 cos x plus 1. That's the derivative of that. 2 cos x plus 1. So the derivative of tan inverse of cos x, derivative of tan inverse of cos x by 1 plus cos x is, first start from outer to inner, first write down the formula for derivative of tan inverse x. Now the x itself is a function, so find its derivative, use quotient rule because you have in the form of u by v. So apply the quotient rule and you simplify a little bit. You will be getting answer as minus of sin x by 2 cos square x plus 2 cos x plus 1. We will do one more. Let's look at this function for which we have to find out the derivative. We have to find out the derivative of sin inverse of b plus a sin x by a plus b sin x. First let me write down what's the derivative of sin inverse x. We'll write it down here. We'll say d by dx of sin inverse x is, we know that 1 by square root of 1 minus x square. After that, what else we have to find out derivative of sin x? So let me write down sin x also. D by dx of sin x is equal to cos x. Okay, here we go. Let's start. First we'll write down 1 by, because at higher level I see first sin inverse, outer to inner. First see sin inverse. Sin inverse is square root of 1 minus x square. X square is b plus a sin x divided by a plus b sin x whole square. After that, I have to do differentiation of b plus sin x, b plus a sin x divided by a plus b sin x, because I have done sin inverse of x, but that x itself is a function, so I should find out the derivative of that. That is a plus b sin x. We are applying chain rule now. Now again, if you go here, you have, this is u and v, you have quotient rule you have to apply. So let us see what is our u, b plus a sin x. What is u dash then? Let me write it down here. Here I will write it down. U dash is derivative of b plus a sin x. That's nothing but a cos x. Because derivative of b is 0, derivative of a into sin x is a cos x. What is derivative of v dash? V is a plus b sin x. So derivative of a is 0, derivative of b sin x is b into derivative of sin x, that is b cos x. Pretty much clear. So let's go ahead and write down the next step. That will be equal to, can I write it as, now if you see here, this I can write it as square root of a plus b sin x whole square, a plus b sin x whole square minus of b plus a sin x whole square. I hope you will agree with me on that. And then I will have a plus b sin x whole square square root, that is nothing but a plus b sin x. So I will have a plus b sin x here too. Okay. Now derivative of b plus a sin x by a plus b sin x is v dash. I have to first write down v square, that is a plus b sin x whole square then I will have v into u dash, that is a plus b sin x multiplied with u dash. U dash we know is a cos x minus v into u dash minus u into v dash. U is b plus a sin x and multiply that with v dash. V dash is b cos x. Now let's try to simplify this further. We will have a plus b sin x divided by let's try to expand this. We will have square root of a plus b sin x whole square is a square plus b square sin square x minus 2ab sin x plus b square plus a square sin square x minus, I have plus here, and this is minus 2ab sin x. You can see 2ab sin x cancels out. I have a square plus b square, a square plus a square sin square x. Okay, we have minus there. So wait a minute, I will have just 1 minute. So we'll have a plus b sin x whole square is a square plus b square sin square x plus 2ab sin x minus of b whole square is b square minus a square sin square x. We'll have then minus 2ab sin x. And we can see that 2ab sin x cancel. We'll have a square minus b square and also b square sin square x minus a square sin square x. We'll write it in the next step. We'll not hurry it up. So we'll have here a plus b sin x whole square, and a into a is a square cos x plus b sin x into a cos x is ab sin x cos x minus b square cos x, b into b cos x is b square cos x minus ab sin x cos x. So you can see ab sin x cos x, ab sin x cos x cancels out. Let's write the next step. The next step will be a plus b sin x will cancel a plus b sin x. So I can write it as a plus b sin x. Can I write it as 1 by a plus b sin x, so that I can simplify that there. Then let's go to the numerator part. What I have in the numerator? I have a square cos x minus b square cos x. So can I say a square minus b square into cos x? That has been taken care. So I don't have anything here. Let's come down to denominator. In the denominator, I have a square minus b square, a square minus b square. After that, I have plus b square sin square x minus a square sin square x. So can I say plus b square minus a square into sin square x? Can I write it as a square minus b square into cos x divided by a plus b sin x multiply with, I can write it as square root of a square minus b square minus a square minus b square of sin square x. Why I am writing that? Because 1 minus sin square x is cos square x, and I can simplify it there. So this becomes a square minus b square into cos x divided by a plus b sin x multiplied with, I can take root of a square minus b square common, and I will be left out with root of 1 minus sin square x, that is root of 1 minus sin square x is cos square x, so I can write it as cos x. See, if this is not clear, I will give you one more step here. The step is, this is square root of a square minus b square into 1 minus sin square x. That's equal to square root of a square minus b square into 1 minus sin square x is cos square x, square root of cos square x is cos x. So you can see cos x cancels, and root of a square minus b square will go root of a square minus b square. So that gives you, the answer is square root of a square minus b square divided by a plus b sin x. Now if you feel this problem is interesting, what I want you to try now is, instead of sin x, take it as, try this problem. Say cos inverse of b plus a cos x by a plus b cos x, and try to find out its derivative. You will get square root of a square minus b square by a plus b cos x. Try it out. Instead of sin, take it as cos. Cos inverse of b plus a cos x by a plus b cos x. Your answer will be square root of a square minus b square by a plus b cos x. You can try that out. So what we have done, first we started with sin inverse. So 1 by square root of 1 minus x square. Then quotient rule, u by v, we have to apply. And we have to do little bit of simplification. And the end result, the answer is square root of a square minus b square by a plus b sin x. I hope that's clear. So that's for this particular session. We have seen couple of examples, a little bit intermediate level examples on inverse trigonometric functions with a combination of chain rules. I'll catch you again in the next session. Thanks for your time and your support. Bye for now.